Hello everyone. So today we are going to discuss some problems from set 2. So the first problem is Joseph is learning a digital logic subject which will be for his next semester exams. He usually tries to solve unit assignment before the lecture. Today he got one tricky question. Problem is a positive integer is given as an input and you have to convert decimal value to the binary representation and toggle all the bits of it after the most significant bit, including the most significant bit, and print the positive integer value after toggling all the bits. So what does it mean? So let's take an example to understand it. So 10, how can we write 10 in binary? So let's just revise that 10 can be written as 2 cube into 1 plus 2 square into 0 plus 2 to the power 1 into 1 plus 2 to the power 0 into 0. So this is basically 8 and this is basically 2. So this is the representation of 10, and for the binary representation we can write it as 1010. Now let's try to understand what the problem statement is saying. Firstly, we have to convert it to binary representation. That's done. Then toggle all the bits after its most significant bit. What is the most significant bit? Most significant bit is the first bit from the left. So basically, before this one, there are multiple zeros present. So they are not significant number. The first bit with the number 1, the first leftmost bit with the number 1 is called the most significant bit. So 1 is our most significant bit. So what we need to do is we need to flip all the numbers right to the 1, including the most significant bit. Means we have to flip 1 as well. What does flipping means? Flipping means that we have to convert 1 to 0 and 0 to 1. So basically we need to take a XOR. Take a XOR with 1 here, we get 0. Take a XOR with 0 here, we get 1. Take a XOR with this here and this, we get this number. We don't flip these bits because these are not significant. So we get this number as a resultant, that's 5, and my output is also giving me the answer as 5. So yeah, this is the problem and we have to solve it. It's a pretty basic problem. So first of all, what we'll be doing is we'll be taking an input, and just like what we do to calculate, to write a decimal representation, we'll be using a while loop. And let's just get the parity of the number here. If my number is 1, also let's get an answer as 0. If my parity is 1, so let's just get the reverse of this number. That will be p XOR 1. Anything, any bit XOR 1 is 0, the reverse of it. So let me write it here. 1 XOR 1 is equal to 0, and 1 XOR 0, 0 XOR 1, sorry, 0 XOR 1 is equal to 1. So yeah, we are just getting the reverse parity of my p. And what we need to do is we just need to uh, update our answer with this value. And for that, first of all, let's take a power of 1. So basically what we'll be doing, let's just write it as po, and po into r, also po into equals 2. So let me explain what I did here. So basically what I'm doing is I'm starting my loop from 10, and then I'm getting the parity of its most insignificant bit. Most insignificant bit doesn't mean the bits that are to the left and that represent zeros only. Most insignificant bit is the rightmost bit only. That's what you need to know. So when I take the mod of 10, I get as mod of 10 with 2, 10 mod 2 is 0. So basically I am getting this particular bit. Then what I'm doing, I'm taking its reverse, or basically its flipped value. That's 0 or 1, that's 1. So my p's value is 1 here. Then what am I doing? I am just adding ans plus equals po into r. Uh, po is basically power of 2. Basically at this position the power of 2 that is represented is 2 to the power 0. That's why po's value is 1. And what I'm doing is basically 1 into 1, and that's the desired output as well, because after flipping what do we get? We get 0 1 0 1. So for this one I need to add 1 into 1 to my resultant. And after that, well, what I'll be doing is, after tens result is done, I need the result for this particular bit. So what I'll be doing is updating my n value to n over 2. That's basic. That's basically how we do it for finding the binary representation. Then I see for this value 1 my reverse value will be 0, and as you can see that a 0 is present here as well. So what we need to do is we need to add 0 into 2 at this position. After this I'll again be updating my 5. This was updated to 5. Again I'll be updating 5 to 5 over 2, and for integer division this comes out to be 2 only. And as you can see, 2 mod 2 is 0, that's present in this position. We take its inverse, my parity against become 1. And as you can see, this is exactly what we desired. And what we'll be doing is 1 into 2 to the power 2. And how we are getting this 2 to the power 2? In every loop we are multiplying po with 2. So yeah, this becomes, initially it stays 1, after first iteration it becomes 2, and then it becomes 4, 8, 16, and so on. So yeah, let's just see if our answer is being printed. Let's take it as 10. Yeah, we are getting the answer. So yeah, this is basically the idea. The main point that you might gain from this is that if you take a XOR with any, if you take a XOR with any bit, you always get the flip of it. And basically this shortens your line for a few if else's. You can also solve it through if else's. You can do it if p equals 1, then r equals 1, r equals 0, else r equals 1. But yeah, this saves you two lines, and it is pretty easy to write as well and easy to remember. So yeah, this is the problem. Now let's move towards the second problem. So Jack is always excited about Sunday. It is his favorite day when he gets to play all day and goes to cycling with his friends. So every time when this month starts, he counts the number of Sundays he will get to enjoy. Considering the month can start with any day, be it Sunday, Monday, or so on, count the number of Sundays Jack will get within n number of days. So basically, you are given two arguments. You are given a string S, which will represent the first three alphabets of a particular day, and then you're given an integer d. So basically you're given Monday and you're given 13. You need to find how many Sundays will given within their these 13 days of time starting from a Monday. So let's look at the explanation. Our output is 2. How so? After Monday there is Tuesday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then a Sunday. A Sunday arrives after 6 days, including Monday. Like from Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, there are 6 days. So first Sunday arrives after 6 days, and then the next Sunday arrives after 7 days. So you can brute force this, but the constraints are pretty tough. Constraints represent that d will be in the range of 10 to the power n, so 10 to the power 9. So 10 to the power 9 is very high for brute forcing, so we need to find some mathematical relation. So let me explain it in the whiteboard first. So from Monday, the first Sunday arrives after 6 days, right? And after it, be it any days, Sunday will arrive after 7 days only. After a Sunday again, a Sunday arrives after 7 days only. So let's consider if we were given Monday, and let's consider 13 plus 7, 20, 20 plus 7, 27. What will the answer for this? after after the first 6 days we'll be getting our solution. After the first 6 days we'll be getting our first Sunday. So after the first 6 days there will be 21 days left after we have arrived at the first Sunday. So basically after 6 my value becomes 1, and after 21 I'll be just subtracting 7 again and again. Instead of subtracting 7, there's a simple solution. I can just divide it by 7. By dividing it by 7 I also get 3, and by doing that loop thing also I also get 3. So my total answer in this case, as I can see, is 1 plus 1 plus 1 plus 1. After using this formula, after 6 I'll be getting 1 plus 3 as 4. 4 is my answer. So let's try to understand how it will work for different days of a week. So first what you need to find is that let's consider Tuesday. After how many days a Sunday will come? If I see a Tuesday, after exactly 5 days I'll be getting a Sunday. So firstly, whatever D I might get, first of all I'll try to subtract D with 5. Right? I'll try to subtract D with 5. What does it mean? That these are the days remaining. These are the days that remain after the first Sunday arrives. So yeah, after d minus 5, after that we just need to find the answer for d minus 5, as we have seen here. That's d minus 5 over 7, and we have also need to include the 5 days after which the Sunday comes, and for that we'll be adding 1 only. So yeah, this is the solution. So we just need to, like, for Tuesday we need to subtract 5, for Wednesday we'll need to subtract 4, and for Thursday it will be 3, for Saturday it will be 1, and for Sunday it will be 0 only. Because for Sunday we know that, like, if you have 21 days after Sunday, including this Sunday, how many there will be, including this Sunday, after the next Sunday will come after uh, 7 days, and the next Sunday will come after again 7 and again 7, so you'll be getting overall 4. So your answer will be 1 plus d over 7. That's 1 plus 21 over 7. That's 4 only. And yeah, even if we exceed some days, like we get 22 or 23 here, that doesn't matter because no Sunday will be coming between these days, and integer division always rounds down to the bottom, the greatest integer function. So yeah, this is basically the idea of solving this problem. You can use if else's, and basically the formula for this problem is 1 plus d minus the let's call it dx over 7, and rounding down to bottom, and rounding down to the lowest integer. What is dx? Dx is the days required days required for the first Sunday. So dx are the days required for the first Sunday to happen. Also there's a condition, the condition being that d should always be greater than or equal to dx. Only then will this equation work, else this goes into negative. And we can also observe that if the first Sunday doesn't even happen within the required quota of days, we're not getting a Sunday ever. So our answer for the case when d is less than dx will be 0 only. So yeah, pretty straightforward question. So yeah, let's, without further ado, let's begin the coding portion. Take the input of s, and we can just form a switch case mon. So for this particular scenario, let's just calculate our dx. Some errors, as type const char instead of string. Yeah, so this will give some errors. So instead of switch, I'll recommend forming an array of 7 mon 2 uh, without array we can also do with if else. If s equal to mon, it means that, so let's start with sun only. It means that dx remains 0. Else if s is mon, my dx value is 1 equals to 2 dx is okay, so sorry, it will be 6, it will be 5. S equals to ved dx is 4. So if s equals to dx will be 3. If s equals to fry, dx is 2. Else the only remaining day is Saturday, I believe. Dx equals 1. So yeah, that's pretty much it. And then we also need to input d. As I said, if d ever is less than dx, we'll just be printing 0 because no Sunday will ever arrive. Else we just need to print d minus dx over 7. So yeah, just print it. And let's look at our test case mon 13. So let's just write mon 13 here. We're getting 2 as an answer. If it was 12, as you can see in our test case, if it was 12 then we'll just stop at Saturday, so the answer should be 1. So let's just see if it works. Yeah, it's working because d minus dx will become 12 minus 6, which is 6 over 7. That will result in 0 and 1 only will prevail. And you can solve it for particularly any test case, and this is the best mathematical solution. Else you can brute force, but brute force would not work and it will give you TLE error in some test cases. So I'll recommend using mathematical solutions for these, in which you can see a pattern. As you can see, after a particular duration, you'll be after a particular duration of days you'll be getting a constant pattern. You can just divide it by 7 and use this as a constant. So yeah, this is a pretty standard format in multiple easy medium problems. So feel free to copy this format in any other problems, and see you next time.